Hi and welcome to another video for Maths D, still on the topic limits of accuracy. Now this is going to be about bounds of measurements, but first of all you have to know about the lower bounds and the upper bounds. Now in finding lower and upper bounds, you have to know how to calculate what we call the absolute error of a measurement. Now this absolute error of measurement here, okay, as we go down, okay, here let's say, now we know that for a fact that all measurements are approximations because we will not get an accurate 100% measurement when we use instruments. Now suppose that a length of piece of paper is measured at 26 centimeter, and when you see this statement correct to the nearest centimeter, it means that the true length of the paper is nearer to 26 centimeter than the closest measurement on each side, which is like here, when you say it is correct to near centimeter, 26 centimeter over here, the boundary will be 25 and 27 centimeter. Now here, to find lower and upper bound over here is that near 26, you have what we have here. This is the upper bound and this is the lower bound. Now to find the upper and lower bound, we calculate the absolute error of the measurement. Now this is the formula that you have to remember about absolute error. Absolute error is equal to half of the units of accuracy. Now here, since we have correct to the nearest centimeter for the first example over here, so we have to multiply half with 1 centimeter because here nearest centimeter. So what you have is that your absolute error will be 0.5 centimeter. Now we know that the paper just now in your first example over here, you have a 26 centimeter, right? So what you're going to do with the 26 centimeter is that when you want to count the lower bound, you have to subtract 26 centimeter with your absolute error. So when you subtract 26 centimeter by 0.5, you will have 25.5 centimeter. And when you want to count the upper bound for your measurement, 26 centimeter will be added with the absolute error. So your answer over here will be 26.5. Now we can also write the length range as here you put the lower bound, which is 25.5, and on the right side, which is the maximum, will be your upper bound, right? And also you can also write this as a 26 centimeter, which is your estimated measure, 26 centimeter plus or minus 0.5, which is your absolute error. Now back to the diagram over here. So since you know your lower bound and upper bound already, so we just have to label this as, you can see here that between 25 and 26 you have 25.5. This is your lower bound, and between 26 and 27 you have 26.5, which is your upper bound. Here, this is another method that you can use to measure the upper and lower bound. Now let's proceed to the example that we have over here now. Example number 1. Por won the 200-meter race in a time of 24.2 seconds to the nearest tenth of a second. Complete the sentence below. So Por's time was between how many seconds and how many seconds? So here we know that 1/10 is 0.1. So what you're going to do is, firstly, you have to count your absolute error. And to count your absolute error, you have to halve your units of measurement. So here your units of accuracy is 0.1. So when you multiply half with 0.1, you will have 0.05. So this is your absolute error. Now with this, we can count the lower bounds. Just simplify this into LB. Your lower bound will be your measurement just now, which is 24.2, second. When you talk about lower bound, you have to subtract with the absolute error. So your lower bound will be 24.15 second, right? And for your upper bound, you can, with your measurement, you have to add the absolute error. So your upper bound will be 24.25 second. So there you have it. You have to fill this in. It was between the lower bound and the upper bound. So you fill 24.15 second and 24.25 second. So that's the first example. You can also use the second method if you are comfortable with it. Okay. Now let's move on to the next one. Okay, example number 2. On a certain day, the turnover of a cafe is $8,600, correct to the nearest 100. So this is your units of accuracy, which is nearest 100. So the question is to find the lower bound and the upper bound of the turnover. So what you have to do firstly is to find the absolute error for sure, right? So absolute error is basically half of the units of accuracy over here, which is nearest 100. So your absolute error will be $50, right, over here. So now we can count the lower bound, which is your turnover, and then subtracted by the absolute error. So your answer will be 8,600 minus 50 is 550. So this is your lower bound. And for your upper bound, it is your turnover, and then you have to add with the absolute error. So which is your upper bound will be $8,650, right? Okay, that's for the second example. So quite simple. Okay, next one is here. Example number 3. Charlie's height is given as 1.76 meter. So this is correct to the nearest centimeter. So this is your units of accuracy for the height. And for the weight, his weight is 61 kilogram, correct to the nearest 100 gram. So what you're going to do is that here, your nearest centimeter is your units of accuracy, right? But your height is given as 1.76 meters. So what you're going to do is to convert this nearest centimeter into meter. So you know that 1 meter is 100 centimeter. So what you're going to do is to convert 1 centimeter to meter, you have to divide it by 100, right? So it will be 0.01 meter. So it is this one. Correct to the nearest centimeter is actually the same as correct to the 0.01 meter. And for the 100 grams, because your weight is given in kilogram, right? So you have to convert this 100 kilogram into kilograms. So here I have given the units for the accuracy. So this is actually nearest 0.001 kilogram. So basically you have to find to complete the table here. So you have to find the lower bound and the upper bound for the height and weight. So over here, okay, let's start. So here you are given the absolute error. You have to find the absolute error first. So for the height, okay, let's start with the height first. Okay, so absolute error will be half times what's your units for measurement for this one? So 0.01, right? So 0.01 meter. So this is for your height. Okay, so you will get 0.005 meter. Now let's start with the lower bound first. So your lower bound will be subtracted with the units of with your measurement just now, which is 1.76 meter subtracted by 0.005. So you will have 1.7 meter. Okay, so this is for your lower bound for your height. And for the upper bound, it is your measured height added with the absolute error. So you will have 1.765 meter, right? So you will fill in this one. Charlie's height for the lower bound and upper bound of his height will be a 1.755 meter, and for your upper bound will be 1.765 meter. Ignore that. Okay, just fill in on under the line, above the line. Okay, let's start with let's begin with the weight. Okay, let's proceed with the weight. So for your weight, the absolute error will be half times your unit of weight is 0.01 kilograms, so 0.001 kilogram, and you will have here my mistake, this is 100 grams, so this is not supposed to be your absolute units of measurement. Okay, sorry for that. So let me just correct this. Okay, actually this one you have to convert 100 grams. So 100, this is not the one, so 100 divided by 1000. So you will have 0.1 kilogram. So here your units of measurement is, your units of accuracy is 0.1 kilogram. So you will have 0.05 kilogram as your absolute error. Okay, apologize for that. So let's proceed. For the weight, okay, the lower bound will be, what's his measure weight just now? His weight is 61 kilogram. It's measured over here. So 61 kilogram minus 0.05. So it will give you 60.95 kilogram, right? Okay, so for the last one, it's your upper bound. So 61 kilogram will be added with your absolute error. So your answer will be 61.05 kilogram. Right? So you just fill in this one. Okay, I expect this will move. 60.95 and 61.05 kilogram. Okay, so basically that's it for the measurement of the lower and upper bound. I hope that the example is simple enough for you to understand. Okay, that's it. Thank you very much and see you next time.